Hey, fourth hour. I promised I'd make you guys a video. Actually, I promised we'd go over some of these problems in class, but I forgot to when we did. So I wanted to make this video for you so you know how to do problems 7 through 10. We did 6 and 7 in class already. Hold on, let me get the right one up. Okay, so, sorry, we're going to start on number 7. So a 110 kilogram car accelerates at 3.4 meters per second squared. So we're going to use that F net equals mass times acceleration equation. And then we are looking for net force. So we're going to use, like I said, F net equals the mass, which is 1,110 kilograms. And then the acceleration is 3.4 meters per second. So the net force is 3,740 newtons. So now we're going to break up these forces and see which one, figure out what just one of them is. So if the wheels exert a force of 5,600 newtons forward, what is the amount of force that is resulting from the movement forward? What is the amount of force that is resisting the movement forward? Okay, so for this one, what we need to do is go F net equals basically force 1 minus force 2. And we're always going to do the biggest force minus the smallest force, so we can figure out what that would be. Okay, so we know that our F net is, and you might have to do this too, you might have to bring this down. Here. There. You can move it when you can see those crosshairs, so you probably know that already. Okay, so F net, so we know the F net. The F net is 3,740 newtons, and that's going to be basically like the applied force minus the friction force. Let me make this smaller and put it down on another line so you can see it better. Applied force minus the friction force. So we know that the applied force is that force that the wheels are exerting on the road. So 5,600 newtons minus this force that we want to find out. Force of, actually let's call it the force of resistance, since it's both friction and air resistance. Oh, goodness. Okay, resist. So another way we can do this is just to rearrange it. So if I want to know what the difference is between the net force and the applied force, I can just do this. I can go 5,600 newtons minus 3,740 newtons equals. You could rearrange that like algebraically and do a whole thing about it, but we know that these three numbers are like a number family, so we know that like this is our bigger force, and the force of resistance is going to be smaller than that, right? Because it is moving forward. So yeah, so 5,600 newtons minus 3,740 newtons is going to be minus 3,740 is going to be 1,860 newtons of resistance. Okay, so then if we're going to draw a diagram about that, it's going to be pretty easy. Just going to be our car and an arrow going this way. Actually, I'm going to put this over here and make it pretty big, because this is our force of like the engine, the wheels, the force that the wheels are exerting on the ground. And then we have another arrow that's going the other direction. Just going to flip it around like that. And this one's going to be a bit smaller, and I'll make it a different color. This one is the force of air resistance, and it's smaller. I'm even make it a little bit smaller. And then we also have the force of friction. So, oh goodness. There. So these two added together are still smaller than this one, and that's why the car is moving forward. Okay, and yes, we should label them. So here we go. Oops. Okay, I think I put all the arrows and stuff on there that I'd want you to put on there. We got our forces labeled with the amount of force that's there. I even labeled the mass of the object and the acceleration going the direction that it's going. So let's take a look at number 8, the graph. So a car traveled through city traffic during rush hour. There was a lot of starting and stopping. This graph shows its motion for a 16-second interval. Okay, so first of all, first thing I want to look at when I'm looking at this is that velocity is on the side here. So I know that I'm looking at, this is the speed. So the speed is starting at 0 meters per second and it's going up. It's going in a forward direction pretty fast, and then it's going in a forward direction a little bit slower, and then it's maintaining that same speed for a while, and then it's going to be decelerating pretty quickly, and then decelerating a little bit slower, and then decelerating to a stop. So let's see what we need to answer here. Okay, so what is going on with the car between A and B? So between A and B, the car is accelerating from 5 meters per second to 7 meters per second. Okay, from A to B, the car was accelerating from 5 meters per second to 7 meters per second. So what happens from B to C? So when I see a flat line on a velocity graph, that means that that the velocity is staying the same for those seconds, okay? So from B to C, the velocity is staying at a constant 7 meters per second. Yeah, that's what we're going to say. Okay, so the velocity stays at a constant 7 meters per second. So then from C to D, there is a quick acceleration, and I can tell that it is a rapid acceleration, or deceleration, I mean, because the slope is steep. So when we're looking at a velocity time graph, the slope is the acceleration. So we are looking at, there is a rapid deceleration from what to what? From 7 meters per second to 4 meters per second. Okay, and then from D to E, all right, D, there is a slower deceleration from 4 meters per second to 1 meter per second. And we could say over 4 seconds. And now I want to write over 2 seconds. Okay, so this is a multi-part question. This is Mrs. Billy actually added these graphing questions to the end of this assignment because she was mad at her students. And this one, like, you can tell. It's funny. I like it though. So the graph on the next slide represents 3 cars during the first minute of the race. Use the following information to draw another line at the grid to represent car D. Okay, car D is a reckless driver. I will tell you that right now. So car D accelerates from a rest position at 0 seconds to a speed of 208 kilometers per hour in 5 seconds. That's not a good idea. Mommy, don't do that.
Chocolate more.
Okay, so this is my
You're
line.
Peanut butter.
I'm a peanut butter? Oh my goodness.
You're a bird.
Okay. So here is this guy accelerating in the first 5 seconds from 0 meters per second to 208 meters per second. Okay, so then it maintains the speed for 5 seconds. All right. So if it's maintaining its speed, then that's going to be a straight line, just right across. There's no change in speed there. So then what? Then the car decelerates to a speed of 160 kilometers per hour at 30 seconds. All right. So at 30 seconds, the car is going 160 kilometers per hour. Okay. So from 10 until 30 seconds. And at 30 seconds, what was it? 160. Okay. And then what? So then maintains that speed for 5 seconds. Okay. So this is going to be another flat line. Okay, and then what? Car D then decelerates to 112 kilometers at 40 seconds. Decelerates to 112 kilometers per hour. 40, so that's over the course of 10 seconds. 112 kilometers per hour. You stay put. Just okay, and then decelerates to 64 kilometers per hour at 50 seconds. 64 kilometers per hour. Okay, so that's like 10 seconds, like that. And then accelerates back up to 208 kilometers per hour at 55 seconds. So from there, back up to there. Okay, so that's what that line looks like. So now we have some questions to answer about that. In 3 minutes, over which time period is car B's acceleration the greatest? So car B is green. So from 0 to 10 seconds. Okay, what is car B's speed at 10 seconds? At 10 seconds, the speed is 192 kilometers per hour. When is car B's acceleration at 0? Only at, okay, so the acceleration was at 0 from 192, or sorry, from 10 seconds on. The acceleration is the slope of the line on a speed time graph, or on a velocity time graph. So this is 0 acceleration right there. And when is car C's acceleration at 0? So car C is pink, and car C's acceleration is at 0, like nowhere really. Like it's just not, it's accelerating a lot here, and it's decelerating a lot here. Yeah, so it's not. Okay, so now we need to know which cars have a negative acceleration during the race. So negative acceleration means a negative slope on this velocity time graph. So, so we have definitely car C, and also car D. Okay, car C and car D. Which car reached the highest speed, and what was that speed? So that's going to be car D, 208 kilometers per hour. Which car may have had a reckless driver? So this, both of these are going to be car D, B, and car D here also, because again, like they were just driving like a crazy person. Which car appears to have stalled, and how do you know? So that's going to be car C, because if their engine stops running, then the applied force goes away, which means that the force of like air resistance and friction and all that stuff is going to start slowing that car down. So car C stalled right there, and that's why there's that deceleration. Okay? The end. Good luck on the test, and yeah, well, you guys have another study day today, but yeah, good luck on that too. Be good for the sub. Okay, bye.